In this video, you will learn how to add and subtract polynomials. Now, before we get into addition and subtraction, we need to know some terms first. So our first term is the word constant. A constant is simply a number. It is something that's not changing. So for example, 2 or 1/2 or 0 or -5, those would all be a constant. Next we have a variable, which is a letter. So we have x, y, z, a, b, etc. So any letter that represents an unknown number is a variable. And variable means changing. All right, so these letters could change. They could be something different each time. So that's why it's a variable. Next we have a coefficient, which is the number in front of the variables. So here we see three examples. If we have 3m squared, 3 is the coefficient because that's the number in front. All right, if you have xy, 1 is the coefficient because there's an assumed 1 in the front. And then if you have negative xy squared, there's an assumed 1 in the front if nothing is written. So this would be a -1. So the coefficient would be -1. Next we have what is called a monomial. A monomial is a constant variable or a product of a constant and one or more variables. So for example, we have 2x would be a monomial. We have a constant, we have a variable, and then it's a product of the two, 2 times x. Here we just have 1, which is fine. We just have a constant. So that would still be a monomial. And then here, 3xyz squared. We have a constant, variables, exponents. This is all being multiplied together. So this would be a monomial. And then y cubed would also work as well. All right. So examples of not monomials would be instead of a product, instead of things being multiplied, if you had division, for example, so 3 divided by x, or negative exponents with the variable, because that means division. X to the -4th power means that we have 2 divided by x to the 4th power. And then here with the radical, with the square root and the variable inside, that would not be a monomial. Next we have what is called a binomial. Binomial would be the sum of 2 monomials. So the prefix bi means 2. So here we have 2x minus y. So 2x would be one monomial, and then y would be another monomial. And it's separated by either a plus or minus sign. Alright, so this would be a binomial. Here we have one monomial, 3x squared y. Here's another monomial, and it's separated by a plus or minus sign. Same thing here. A plus b, we have 2 monomials being added together. So that would be a binomial. Trinomial is the sum of 3 monomials. Tri means 3. So trinomial would be 3 monomials. So here we see 3 different examples. We have 1, 2, 3 monomials. Here we have 1, 2, 3 monomials. And here we have 1, 2, 3 as well. And the key is that they're separated by a plus or minus sign. And then we have the term polynomial. A polynomial just means any number of monomials. So it could be 1 monomial, or it could be 10 monomials. So polynomial is really the bigger term. And under polynomial, we have all these other specific types. We'd have monomial, binomial, and trinomial. The polynomial would include those, but also it includes things with more than 3 terms. So here, for example, we have 1 term, or 1 monomial. That would be a polynomial. Here we have 2 monomials. That would also be polynomial. Here we have 1, 2, 3, 4, 5. That would also be a polynomial. So any number of monomials being added together would classify as a polynomial. Next we have the word term. A term would be each monomial within the polynomial. So, for example, looking back up here at the x, that only has one monomial, so we can also say this has one term. A plus b, we have 1, 2 terms, or 2 monomials. Here we have 1, 2, 3, 4, 5 monomials, and we can say each one of those is a term, so that has 5 terms. Alright, here's some other examples. If you have 3xy squared plus 2x minus y, term 1 is the first monomial, the first term. So 3xy squared is term 1. The second term would be 2x. That's your second monomial. And then the third term would be negative y. That's your third monomial. And then we have what's called similar or like terms. Those are terms that are identical or only differ in their coefficients. So as long as the variable component is the same, then they would be considered like terms. So for example, 2x and 4x are similar because the variable part is the same. They both have an x. Alright, 2x and 4x squared are not similar because those are not the same. X is different than x squared, so those are not like terms. Next we have what is called the degree of a variable. The degree of a variable is the exponent with the variable. So for example, you have x to the second power. The degree would be 2 because that is your exponent. Y to the third power, you would say the degree of that expression is 3 because the exponent is 3. Z to the fourth power, the degree would be 4. A to the fifth power, the degree is 5, and etc. Now here, if there is no exponent, it's an assumed 1 because there's 1b here. So the degree of this expression would be 1 because the exponent is an assumed 1. So then, once you know the degree of a variable, you can use that to find the degree of an entire term. So the degree of a term is found by adding all the exponents of the variables. So for example, 3x squared. You add all the exponents with the variables. So here, there's just the x squared. That's the only variable part. So the degree of this would simply be 2 because the exponent is 2. But if you start putting in other variables, so now we have 5x cubed y squared. To find the degree, I just look at the variables. So I can ignore the 5, and I can look just at the variable part. So what I do is I add the exponents of the variables. So 3 plus 2 would be 5. So the degree of this expression would be 5. Here's another one. X to the fifth times y to the seventh power. So here, you add the exponents of the variables. 5 plus 7 means the degree would be 12. Here we have 4x to the fifth times y. So we could ignore the coefficient, the 4 in the front, and we just look at the variables. So the exponent here is 5. The exponent with y is 1. 5 plus 1 gives me 6. Now, if you don't have any variables, say you just had the number 5, there is no variables, so there is no exponents, so the degree would be 0 in this case. And a way we could think of this is we could think of this as x to the 0 power, right? Because x to the 0 power would just be 1. That is the same thing as saying 5 times 1, which would equal 5. So you don't write x to the 0 power because it's not needed, because it's just 1, but that could be another way of seeing why the degree would be 0. So we found the degree of a variable, we found the degree of a term. Now what if you have multiple terms being added together? So that would leave us with a polynomial. So for a polynomial, the degree of a polynomial would be finding the largest degree of its terms, and do that after it's been simplified. So for example, here we have 10x squared plus 5x to the fourth plus 3. Looking at term 1, the degree of this would be 2. And then term 2, the degree of this would be 4. And then term 3, there is no variable, so there is a degree of 0 for term 3. So the degree of the entire polynomial is found by taking the largest one. So the largest one is here, the second term, and that was 4. So the degree of the entire polynomial would also be 4. Okay, here's another example. We have 8x squared y plus 2x squared y cubed z to the fifth plus 4. So to find the degree of the entire polynomial, I look at each term separate. So the degree here, we look at the variables, 2, then there's a 1 here, so 2 plus 1 would be 3. So the degree of that term 1 would be 3. Term 2, I have 2 plus 3 plus 5, which would be 10. And then term 3, there is no variables, so the degree is going to be 0. Now the degree of the entire polynomial is found by taking the biggest one, which was term 2. Term 2 had a degree of 10, so the entire polynomial also has a degree of 10. Now this is useful when you have to arrange a set of terms. You want to arrange typically in descending order, meaning the biggest degree term goes first, and then the next one comes second, and then the next one third, etc. So here we see an example. If you were to arrange in descending order, what that means is we start with the bigger exponents first and then go down from there. So the 5 to the x, or 5x to the fourth power, we'd want to write that first, and then we have the third power, so 2x to the third, and then the second power, the minus x squared, and then the first power, plus 3 times x. So notice it's in descending order by degree. The degree here is 4, then 3, then 2, then 1. Alright, and now we need to know how to add and subtract. So here you have two polynomials, and in this case you're told to add. When you're adding polynomials, you pretty much can just get rid of the parentheses, because when you add, it means you're adding everything in here. So you're adding a 3m squared, you're adding an m, and adding a negative 5. So if you distribute that adding to every term, it doesn't really change anything. So here we can then combine. So we have 2m squared plus 3m squared. Those can combine because those have like terms. So we have 2 and then 3 more. That's going to give me 5 of those. So we have 5m squareds. And then looking at m to the first power, we have a negative m and a positive m. Those are like terms because the exponent is a 1, and we can add them. Negative 1m plus 1m. Negative 1 plus 1 would give me 0. So those actually cancel out. And then we have the 4 minus 5 can combine. 4 minus 5 would be negative 1. So I can write this expression in its simplified form as 5m squared minus 1. Alright, here we have three sets of polynomials, and we're adding still. So when we are adding, we can pretty much just get rid of the parentheses. Alright, so here we have the same thing, just without parentheses. Now to combine like terms, I need to see which ones have the same variable component. So 2x to the third, there's nothing else that can combine with it. There's nothing else with x to the third. So that just stays by itself. And then we look at x squareds. Here we have 4x squareds which that cannot combine either. There's no other x squareds listed, so that's by itself as well. And then we have 8x to the first power and negative 9x to the first power. Those are like terms because they both have the same variable component. And they can combine by taking 8 minus 9, which would equal negative 1. So I have negative 1x or just negative x, same thing. And then the numbers, we have negative 4 plus 7. Negative 4 plus 7 can combine, and that would give me a plus 3. So this set of polynomials can simplify, and you would get 2x to the third plus 4x squared minus x plus 3. Now be careful when you're subtracting polynomials, because when you're subtracting everything inside. So we have here the 3x squared plus 4x minus 10. That can stay there. But then you're subtracting a 5x squared. So subtracting 5x squared. You're subtracting a negative 3x. So when you subtract a negative, that becomes a positive 3x. And then subtract a 7 as well. So that becomes a minus 7. So be careful that you are distributing that negative to every part within the parentheses. So then from here, I can simplify. So 3x squared minus 5x squared, those can combine. So 3 minus 5 would be negative 2x squareds. And then looking at the x's, we have 4x's plus 3 more x's. That gives me 7x's. And then negative 10 minus 7 can combine to get negative 17. So my simplified form would be negative 2x squared plus 7x minus 17. Here's another example where you are told in words what to do, and you have to set up the expression on your own and then simplify. Here we are told to subtract 8x cubed plus 9x minus 5 from 15x cubed minus 4x squared. So be careful that you're doing this correctly. You're subtracting this from 15x cubed minus 4x squared. So if you're subtracting this, that means you take the 15x cubed minus 4x squared and subtract 8x cubed plus 9x minus 5. So the temptation might be to do it the other way. So just be careful, and that would be your setup. And then from here you can simplify. So just be careful once again with the minus. So here we have 15x cubed minus 4x squared. Then we have minus 8x cubed. And the minus goes to everything. So minus 8x cubed minus 9x and minus a negative 5, which minus the negative would be a positive. So we have this expression that we can then simplify by combining like terms. So we see the x cubes can go together. 15 minus 8 would give me 7x cubed. And then x squareds, there's only that, so that just stays by itself. X to the first power, so negative 9x, that's by itself as well. And the plus 5 is also by itself. So the only thing that can combine would be the x cubes, and your final expression would be 7x cubed minus 4x squared minus 9x plus 5. One more example, we see here that we need to distribute and then simplify by combining like terms. So the 4 I need to distribute, and then the 3 I need to distribute. So I do that first before I combine. So 4 times 3y squared would be a 12y squared. And then 4 times negative 2y would be a negative 8y. 3 times y squared is 3y squared. 3 times 5y is 15y. And 3 times negative 1 is negative 3. So I have that expression where now I can combine like terms. we have the y squareds combined. 12 and 3 give me 15y squared. And then negative 8y plus 15y, those are like terms as well. So negative 8 plus 15 would give me a positive 7y. And then the minus 3 out here at the end. So my simplified form would be right here. We have 15y squared plus 7y minus 3. And nothing else can combine. So that concludes our lesson for today. We will see you next time.